Okay, so I retyped this, and now it says algebra 1, which is, in algebra 1 you do the secant line, which really is just the equation of a line, y2 minus y1 over x2 minus x1, to get the slope of it, and that's the average rate of change. These are the same thing. The slope of the secant line, the algebra 1 slope, is the average rate of change. Calculus, it's the tangent line, the slope of the tangent line, which is also the instantaneous rate of change. They're the same thing. So what I'm showing you is we kind of did that. We did the derivative here in calculus in blue. We did the algebra 1 slope here in red, right here. y2 minus y1 over x2 minus x1. So we got 9 for that. Now what you're doing is you're taking those two things right here and you're setting them equal to each other. Be aware that a polynomial will always be continuous and differentiable. So this will be continuous and differentiable. And here we are kind of going through it. You can kind of see what's going on. So I don't know what to do here, but let's just say we're good. Set them equal, right? Set it to 0, factor out the 3, factor it, and here are the two values. At either of those two values, this function's slope, the derivative, the slope of the tangent line, will be the same as the slope of the secant line, the slope between those 2 points. The slope between these 2 points. So that's the slope from, I think, from -5 to 1. So if you were to graph this from negative, and we're looking at the interval from -5 to 1, so when we look at these two c values, this is good. This is where it goes from, but this isn't really inside of the interval, so I don't even know if we need to pay attention to that one. Because that's the very end, right? So it's really c equals -3, which is between -5 and 1. Okay. So let's look at this page, and there's a few things that are going on here, unfortunately.
Were you able to read that little part? Yeah.
So when we're looking at this problem right here, Billy Joe Longlegs runs a 100-yard dash in 20 seconds. So what is his rate of change average? He goes 100 yards, and it takes him 20 seconds, right? So how do we figure that rate of change out? And I don't want to use red because I'm using red down there. So 100 yards in 20 seconds. So I'm going to go ahead and put 100 is the change in position, 20 is the change in time, right? And that's going to be 5 yards per second. That's how fast he's going. From 0, right? From the interval 0 to 20. The first 20 seconds. It's only 20 seconds. That's all he's doing. And if that's the case, and everything's like normal here, like normal, then he must have been going that exact same. The average rate of change at some time, we don't know what that time is, but must have equaled 5 yards a second. It's a certainty. Let's look at this example. At 7 p.m., so why don't we call that t equals 0? So we'll call 7 p.m. t equals 0. A car is traveling 50 miles an hour, so we could even call that just y1 is 50 if we like. 10 minutes later, well, we're not going to deal with that. We're just going to call that t equals 10. The car is slowed to 30 miles an hour, so why don't we just call that y2 equals 30. Okay, and that's kind of where we're at here. So now we need to show that sometime the car's acceleration was exactly 120 miles per hour squared. And we got to be careful, I guess, because we're talking about hours here and we're talking about minutes here. So watch out, I made that mistake when I originally did this problem. Now I kind of see what's going on. So what's the change here? So we have 30 minus 50, y2 minus y1. So that's -20 is the top over, and it's 10 seconds, right? 10 seconds. So it's -20 miles per hour time divided by 10 seconds. So we got to kind of like make some sense of that units wise. Units are really the only issue here. So let's think about it. Well, if I have this right here, negative 20 miles per 1 hour. And now I want to divide by 10 seconds. That's 1 over 10 seconds. Do you see what I'm saying? And I want this in, I think, hours, because you can kind of see this is the answer is 120 miles an hour. So how can I change this? How can I get rid of this seconds? Oh, sorry, this is minutes. Oh, gosh. Minutes. 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 So 60 minutes equals 1 hour. And now this will cancel, getting us, I think, negative 20, negative 120, because I'm going to multiply the 6 right here by the negative 20. So negative 120 miles, because the miles didn't cancel out, per, how many hours do I have on the bottom? I have hours, and I have hours again, so I have hours squared. So this is how fast, or this is his acceleration or his deceleration in that 10 minutes, right? And if that's the case, then he must have at some point been, and there's the negative sign right there, you see that? That negative sign goes here. At some point, there must have been exactly that speed, that acceleration. Okay? So these are a couple that just worked out. Those same problems worked out. And I want you to try this one. If you had the mean value theorem going on here, and I told you that C was, I just wanted you to find C using the mean value theorem from 0 to 3. And remember, this is an x value, and this is an x value, okay? It's not an x and a y. Try to use the mean value theorem on this problem if you can. If you can't, tell me why you can't, okay? Think about continuous and differentiable. Pause the video, give that a shot. And we're hoping that that went well. And then lastly, you're probably going to want to pause the video and try this one, but I might set you up with this, okay? So we got 2 stationary control cars, and truck passes the first car. Its speed is clocked at 55 miles an hour. So I'm going to say, Y1, right? The original speed here was 55 miles an hour. And then 4 minutes later, that's Y2. That's the new value of the speed. It's 50 miles an hour. Okay. Now, when did Y1 happen? That's when he's initially clocked. So this is the time, and that's 0. And when was the speed the radar gun hitting this guy at this point at 50? Well, that was 4 minutes later. So I'm going to call that 4. And that's really what we have here for this thing. Prove that the truck must have exceeded 55 miles an hour at some point. So think about that and maybe flip back and try from a different example, and then you try that on your own. Pause the video, try that on your own. So lastly, what I want you to understand is basically this is what you're doing here. Once you've tried that problem, you're here. You want to know that this is basically what the goal is. To set the derivative equal to the algebra 1 slope. Set the y prime equal to y2 minus y1 over x2 minus x1. Then find x. Solve it. You've got to make sure it's continuous and differentiable, which is important. And what exactly does that mean? Well, here's the deal. When you're looking for something to be differentiable, I'm sorry that there's so much information here, but let me just try to highlight some things literally. When you're looking for something to be differentiable, okay, what you're doing is you're just taking the derivative, right? And you're looking at that, and you're saying, is it okay? So this is how you find out if it's differentiable. You take the derivative, and you look at that answer, and you say, is this okay? And it's not okay if x is equal to 0, so it's not differentiable when x is 0. If you plug 0 into the derivative, aka, it won't work out. So could I do this problem right here, y equals 1 over x, on this interval? No, because it's not going to be continuous. It's not going to be continuous at 0 for sure, but it's also not going to be differentiable at 0. So usually if it's not differentiable at that point, it's usually not continuous either. But you want to look at the continuity of the original function, jump hole, asymptote, And then you want to look at the continuity and the, like, undefinedness, I don't know how else to say that, of the derivative as well. So just take the derivative and inspect it, basically. And that's pretty much all we want to do. I guess I've kept the video a little shorter here, so hopefully that helped. And I will see you in the next video. Good luck.